Tetris, when you complete a level, all of that potential energy goes ka-chunk. Yeah, are you picturing this? Right, so it's the nucleus, and the thing you need to understand is that there's energy levels in the nucleus. Okay, so here it is again. First, the daughter nucleus in an excited state, then the emission of radiation, which was my sort of my bark. Okay, kind of a thing, like a key-op, as it were. Okay, are we ready for this? See, notice that the emission was like pure energy? Wasn't any stuff that went out? Yeah, there we go. Okay, so the nucleus has energy levels. The energy is emitted as a high energy photon, and typically gamma rays are like 5 to 0.05 nanometers. Guideline, yeah? And there are many energies possible. Oh, I was showing something. Momentum lab. Stop by meters of lead. We know all this, don't we? Yeah? And you can use these for food irradiation. They're so deadly and they're so penetrating that you can stick a gamma source in a room full of like ground beef and kill all the E. coli. The beef's already dead, yeah? And you can kill the E. coli. Like E. coli is like living, right? And basically if you have ground beef, you want everything to be dead, yeah?
Wait,
right?
Hold on. Would that be, wait, then how would you do that? Like,
No. Understand what I didn't say. I didn't say we mix the radioactive material into the ground beef, right? I'm saying that you can take ground beef and put a gamma source, if it's hot enough, near it for some period of time, and it will give every DNA particle a fatal hit on the E. coli, right? What's it doing to the beef? Well, it's not doing nothing to the beef, right? And it's not altogether clear that it's doing something bad to the beef, but it's not doing nothing to the beef if it's killing the E. coli, right? So, you know, there we have it. To be sure, when they do it, the gamma source is in some sealed thing, you know, stainless steel or whatever, and it is a very effective way to sterilize stuff, right? But I'm going to let somebody else eat that beef for about 30 years before I'm going to try it. Yeah.
If you were to eat gamma meat, would you become the Incredible Hulk?
If you ate the gamma source, maybe. Yeah. Yeah. There we have it. Keep in mind that just getting irradiated wouldn't just kill you, right, like that. Okay. But you would no longer, your cells wouldn't be able to divide. Right. So it'd be like Hiroshima. Do you guys read that terrible book? Yeah. You would be like one of those people that were like the Walking Dead. Their cells can no longer divide properly, right? Okay. Now take a look at this. Okay. This is bismuth decaying to, is that tellurium or something like that, right? If you look at it, these are the energy levels that it can leave the nucleus in. This is the percent that take that particular path, right? And so a certain percent, I don't know what percent, what is that? 0.01% actually take a path to here. Some of them leave the thing in this state, some of them leave it in that state. These are the allowable transitions. Okay, and this all, by the way, I just got that. I just did a cut and paste from that Korean website that I've shown you. Okay, South Korean, we hope, right? Okay, but anyway, these energy levels used to be in this ginormous book that we all had to borrow. Like there was one copy because it was so expensive, right? This is like, you know, this is generated on the fly from some experimental data. That guy just gathers experimental data. This GIF is generated on the fly from that data, which is just an amazing thing, right? And so, yeah, when you look at this thing, you can get all of these things, and they are like spectral lines, okay? And so the example that we had, and this is the last example, right, is that tellurium-208 emits a 0.6210 MeV gamma, and the neutral atom has this mass. What is the mass before the gamma was emitted? Well, it's the same calculation as this, yeah? So put this calculation in your notes. If it's going to emit... Yeah, this is when we talk about it being discrete. That's what we're talking about, is that it's It's this particular energy level. These are the gamma rays you can get, and you get nothing else from this particular decay. They're allowed. Those are the allowed ones. Okay. So basically the mass is, it becomes 207.98200047, right? Plus 0.6210, right? So this is MeV, right? This is MeV per U, right? And so basically what we're doing here is we're calculating the mass of that gamma ray, and we're going to add it to the mass of this thing. Yeah? Does that make sense? And so the answer I get for that is that's a tremulous sound. Sounds like a little animal. I got it. Yeah, here's what I got. So this side of the equation, the excited state has to be 207.9826714. So when you look, concept zero is when you look up these masses of the nuclei, it's in the unexcited state. It's in the Kenny G, not the speed metal state, right? Yeah, Kenny G. Why is my textbook burned right here?